In this problem set, we're going to factor polynomials, and we're going to use all different types of techniques to factor the polynomials. All right, in this first example, we see that in this polynomial we have some common factors. In fact, 6 divides 12 and 6 also divides 18, so that's a common factor. So we'll start by pulling out the common factor, or in fact we'll try to pull out the greatest common factor of both terms. Okay, so let's see. We'll put the common factor here in front. So we mentioned that 6 is the largest number that divides both 12 and 18, so we'll put that here. And then we look at the powers of x, x to the fifth and x to the fourth, and x to the fourth divides both. In fact, we pull out the smaller power, x to the fourth. And then we have y cubed and y to the fifth, and again, pull out the smaller one, pull out y cubed. And z is the factor of the first term, but not of the second term, so we can't pull that out of both terms. So we don't pull out the power of z. And now let's see what's left in parentheses. Well, from 12 we pulled out factor 2, and we're left with, factor 6, so we're left with factor 2. 6 times 2 is 12. All right, we have x to the fifth. We pulled out x to the fourth, so we're left with x. We pulled out the y cubed, and the z was not pulled out, so put that in. And here we have 18. We pulled out factor 6. We're left with factor 3. 6 times 3 is 18. X to the fourth was pulled out. From y fifth, we pulled out y cubed, and we're left with y squared. In number 2, we have 3 terms, and we see we do have common factors. There's 7 divides all 3 coefficients, and so we'll start by pulling that out. 7 is the largest number that divides all 3 coefficients. Okay, we have an a cubed, an a to the fourth, and an a cubed, so the largest power in all 3, that would be a cubed. Just pull out the smallest power. Okay, that's okay. Now the powers of b, we have b squared, b, and b. So pull out b, pull out the smallest one, and c only appears in the first term and not in the others, so we can't pull out a c. Okay, so let's see what's left. From 14 we pull out factor 7, we're left with factor 2. The a cubed was pulled out. From b squared we pulled out b, and we're left with b. And c remains. From 21 we pulled out factor 7, we're left with factor 3. We pulled out a cubed, we're left with a. And the b was pulled out. All right, let's look at the third factor. We pulled out 7, we pulled out a cubed, we pulled out b. So this is important. We're left with factor 1. Don't forget that 1. If you don't include the 1, then when you multiply back, you won't get that third term, 7a cubed plus b. We only get that third term because of the 1 that's right there. In number 3, we don't see common factors, all right, so we're going to use a different technique. Well, here we have 2 terms, and both terms are perfect squares, so this is called a difference of 2 squares. All right, this is a perfect square. That's 6x squared, and this is 7y squared. So let's write this as a difference of 2 squares. And we have our formula for factoring a difference of 2 squares. It goes like this. A squared minus b squared is equal to a plus b times a minus b. So in this case, this is a, 6x, and b is 7y. All right, so we factor this as a difference of 2 squares. We put 6x plus 7y in the first set of parentheses, and 6x minus 7y in the second. Next example is also a difference of two squares. 16 is 4 squared, and 25y squared, that's 5y squared. So again, factor this as a difference of two squares. Make sure to put the 4 first, because the 16 comes first here. And here we have 4 minus 5y. So we're using that same formula that we saw before. A squared minus b squared is a plus b times a minus b. Okay, again, in this example, we don't have any common factors, and we have a difference, and it happens to be, again, the difference of two squares. Z to the fourth is a perfect square. In fact, any power with an even exponent is a perfect square. The square root will be, we take the square root by just taking half of that exponent. Okay, so let's write this as a difference of two squares. Z to the fourth is z squared squared, and 49 is 7 squared. So let's factor this, and that's z squared plus 7, and then we have z squared minus 7. In number 6, we see that we do not have any common factors, and we don't have a difference of two squares, but we do have is a difference of two cubes. We recognize that 27 is a perfect cube, 3 cubed, so is x cubed, and 8 is 2 cubed. And so let's just write this first as a difference of two cubes. So this is 3x cubed minus 2 cubed. And we're going to use our formula for factoring a difference of two cubes, and it looks like this. A cubed minus b cubed is equal to a minus b. A squared plus ab plus b squared. So in this case, that's a is 3x, and that's b. b is 2. Okay, so let's just fill this in. Here's the small set of parentheses, and here's the big. In the small set, we put 3x minus 2. And here, let's remember, everything is positive, so we're going to take a squared, that's the 3x squared, that's 9x squared. Then multiply these two together, that's for ab, that's 6x. Then square this, so that would be plus 4. In number 7, again, the first thing we always look for are common factors, but we don't have a common factor. We don't have a difference of two squares, but we do have a sum of two cubes. 64 is 4 cubed, and here we have x cubed, and 27 is 3 cubed. So this is a sum of two cubes. So first let's write it like a sum of two cubes. Something cubed plus something cubed. Okay, so that's 4x goes here, and 3 here. And let's write down our factoring formula for a sum of two cubes. A cubed plus b cubed is equal to a plus b. And here we have a squared, here we have minus ab, and here we have b squared. So remember, in the sum formula, there's a negative sign over here. Okay, so let's just use our formula and fill in. Here we fill in with the sum, 4x plus 3. Okay, and now right here, we just square that. Square the first term, we have 16x squared. There's a minus sign here. Multiply these together, and we have 12x. Square this last term, and that's a plus 9. Okay, here we do not have common factors. We have a sum, and we notice that we do have a sum of two cubes. X to the 6 is a perfect cube because 6 is divisible by 3. All right, so let's write this as the sum of two cubes. Cube root of 27 is 3. The cube root of x to the 6 is x to the, just divide 6 divided by 3 is 2. And here 8 is 2 cubed. And we're going to use our sum of two cubes formula. Here we write in the first parentheses 3x squared plus 2. All right, for this term, just square this and we get 9x to the 4th. All right, in the sum of two cubes formula, there's a minus sign right here. And now multiply these together and we have 6x squared for the middle. And square this for the last term, that's plus 4. In number 9, we notice that we do have a common factor in these two terms. We can factor out a 10 and an x. So let's start by doing that. We'll factor out 10x. Okay, so here we pull out 10 and we pull out an x from x cubed and we have x squared. Here pull out 10, we're left with 9 and the x was pulled out. And then we should notice that x squared minus 9 is a difference of two squares. So we can factor this again. Make sure to bring down the 10x. And then factor the x squared minus 9 as x plus 3 times x minus 3. In number 10, we have a quadratic, and we're going to factor this using reverse FOIL multiplication. So let's start by writing out two sets of parentheses. Now we know by the way FOIL works that the first times the first is the first, so this times this is x squared, so we fill that in with xx. Now the last times the last is 15. So we can fill this in with 5 times 3 or maybe 15 times 1. There's only one answer. If we fill it in correctly, then the middle term will come out to be 8x. All right, so let's fill in with 5 and 3. Okay, and let me mention that we could have used minus 5 times minus 2. That'd still give us a plus 15, but then we wouldn't get a plus 8x in the middle. Okay, let's see if we do get the plus 8x. We always have to check outer and inner. Okay, so the outer is 3x, the inner is 5x, and if we add these together, we do get 8x. So that's our check to make sure that we did factor correctly. In number 13, we notice that C is negative. C is less than 0. All right, so let's look at this little rule. If C is less than 0, then we fill in our parentheses with different signs. It'll be plus minus or minus plus. I'll always start with plus minus, and if necessary, I'll switch. Okay, so let's look at this example, x squared plus 7x minus 30. So we're going to fill in the parentheses with a plus and a minus in order to get a negative c value. All right, we'll fill in first with xx. Okay, now 30, again, we're looking at 30. It can be factored many different ways. We have 10 times 3 or 15 times 2. And we want to get that 7x in the middle. Okay. And remember, one is positive and one is negative. Okay. So if we fill in with, let's say, a 10 and a 3, since one is positive and one is negative, 10 minus 3 will give us the 7x. Let's just make sure that's correct. Here we have a 10x and a minus 3x, and we do get a 7x. So that's the correct factorization. Here again, we have an example with the last term, the c term, is less than 0. So we're going to put down our parentheses and fill in with different signs. Now for the first times the first, here we have 3x squared, so I'll fill that in with 3xx. And here we need two factors of 8, two things that multiply to 8. So that could be 8 times 1 or 4 times 2. All right, let's say we try by filling in with a 4 and a 2. And let's just see what we get. So here we have 4x. Here we have minus 6x. That's minus 2x. So no, that doesn't work. Okay, let's try switching it. Let's try 2 and 4. And, okay, I'm going to cross this out. Again, you must check the middle term. So here we have 2x, and here we have minus 12x, and we get minus 10x. So if we have the middle term but with opposite signs, like we have here, then what we do is just switch these signs, make this a negative and this a positive, and that'll be the correct factorization. So the correct factorization is 3x minus 2, x plus 4. So again, if we do our check of the middle term and we end up with the opposite sign, okay, the correct term but with opposite signs, then we switch our signs. In number 15, we have a polynomial with 4 terms, and very often the technique that we use in that case is called grouping. And grouping consists of grouping together the first 2 terms and the second 2 terms and pulling out common factors from each. That's step 1. So let's do that. Here we can pull out x squared. If we pull out x squared, we're left with x minus 5. And from the second group, we can pull out 3. And if we do that, we're left with x minus 5 again. So if that happens, if we're left with the same factor in parentheses, or the same little polynomial in parentheses, then we can actually factor out this entire polynomial. So let's put one copy of the x minus 5 on the side. And if we pull it out of this group, we're left with x squared. And we pull x minus 5 out of this group, and we're left with 3. So that's called factoring by grouping. And it works only in very special cases, where we end up grouping together and we get the same polynomial in parentheses in both groups. Number 16, again, we have 4 terms, so we're going to try grouping again. Pull out x squared from the first group. and we're left with x minus 2. Now here we have this negative symbol, so pull out a negative if possible. So we could pull out minus 3. And here we'd be left with x. And if we pull minus 3 out of plus 6, we're left with minus 2. Just multiply back and make sure that that's correct. Here we have minus 3x, and here we have plus 6. Minus 3x plus 6. Now let's pull out, we were left with the same polynomial in both groups. So we'll pull that out, put one copy of the x minus 2 in front. And we pulled it out of the first group, and we're left with x squared. Pull it out of the second group, and we're left with 3.